You know that nightmare, right? Yeah, the one where you're desperately managing 50 different versions of the exact same sales report just to make sure your regional managers don't accidentally see each other's data. Or, worse, the intern somehow getting their hands on the HR payroll numbers. It's a massive drain on your time, an absolute maintenance headache, and honestly, a compliance disaster just waiting to happen. Well, welcome to The Explainer. Today, we are going to permanently cure that exact nightmare by mastering row-level security in Power BI.
Okay, so here's our roadmap for this explainer. We'll start with the data security challenge, define what row-level security actually is, and then compare static versus dynamic RLS types and uses. After that, we'll cover exactly how to configure RLS, how to test your setup, and finish up with some best practices and pitfalls.
Section 1. The Data Security Challenge, the Dashboard Duplication Nightmare.
Let's kick things off with the ultimate governance dilemma. If your organization shares dashboards across multiple departments, different regions, or external clients, you simply cannot have everyone seeing the exact same numbers. I mean, a sales manager in New York should only see New York sales, right? So how do you secure one single report for 1,000 different users without exposing sensitive corporate data? Historically, people just duplicated the file 1,000 times, created all these siloed datasets, and basically just prayed they remember to update all of them whenever a single metric changed. We are definitely not doing that. It is inefficient, it's error-prone, and it scales terribly.
The answer to that dilemma is our hero for today. One model, hundreds of users, zero duplication. Instead of copying and pasting the same file over and over to create isolated data islands, we can build a single intelligent dashboard full of high-quality visuals. And I say intelligent because it dynamically changes its data view based entirely on who is opening it, with absolutely no manual intervention from you once it's set up.
Section 2. What is row-level security? Filtering data based on identity.
Let's peel back the curtain and see what RLS actually does behind the scenes. Fundamentally, row-level security restricts data access at the row level. When a user opens a report, Power BI evaluates a DAX filter expression in the background, and then it filters the data set right at the source. Think of it kind of like an invisible bouncer standing in front of your data tables. The report structure, your carefully crafted, high-quality visuals, your KPIs, your drill downs, that all remains exactly the same. But the bouncer only lets the authorized rows of data into the VIP section for that specific user. The rest of the data is completely hidden, meaning they literally cannot slice, dice, or export their way into seeing something they shouldn't.
To put that into perspective, think about this contrast. An administrator without restrictions logs in and sees all regions and the total company sales of $730,000. But when the North Region manager logs in, the RLS filter intercepts their query before those visuals even render. They only see the North Region row, and their total sales perfectly reflect just their $200,000. The underlying data model still securely holds the entire $730,000, but the user's view is seamlessly and safely restricted.
Section 3. Static versus dynamic RLS. Choosing your security architecture. Now, you essentially have two architectural choices when exploring RLS types and uses: static or dynamic. Static RLS is super simple, but it's rigid. You hard-code rules directly into the role. You literally write a DAX filter that says region equals West, name the role West managers, and then manually drop users into that bucket in the Power BI service. Look, for a team of 5, absolutely fine. But imagine the absolute chaos when Bob leaves, Sarah shifts to the East region, and you have to manually update 50 static roles every single week. It's unmanageable. That is why we have Dynamic RLS. This is the gold standard for enterprises. Instead of building thousands of hard-coded roles, you create one single intelligent role. It uses DAX to automatically detect who is logged in and then filters the data based on a centralized security mapping table. It is fluid, totally data-driven, and infinitely scalable.
For Dynamic RLS to work its magic, you need a security mapping table. Basically, you tie a user's corporate email directly to their specific data permissions right inside your data source. When Sarah logs in, Power BI checks this mapping table and filters her view to the North region. When James logs in, boom, he gets the South. In a real-world enterprise, you'd usually sync this table directly with your HR system or Azure Active Directory, so onboarding and offboarding are handled completely automatically. And check out that executive row. You can even accommodate an all parameter. You just pass a special flag in your DAX logic to give execs unrestricted access, which completely eliminates the need to build a separate executive reporting structure.
Section 4. How to configure RLS. From desktop to service.
So, how to configure RLS in practice? It's actually a foolproof 4-step workflow bridging your local machine and the cloud.
First up, in Power BI Desktop, you go to the Modeling tab to define your roles and write those critical DAX filters. This establishes your logical rules. Second, still in Desktop, you test that logic locally using the View as Role feature. You got to make sure your DAX is catching the right rows. Third, you publish the dataset up to the cloud in the Power BI service. And yes, your local roles travel right along with the dataset. Finally, inside the service, you navigate to the dataset security settings and assign your actual users or, highly recommended, your Azure Active Directory groups to the roles you just published.
If you are going the Dynamic RLS route, this specific piece of DAX code is about to become your absolute best friend. User email equals user principal name. Think of user principal name as that invisible ID badge reader we talked about. When someone opens the report in the Power BI service, this function reads their authenticated corporate email address, matches it against the user email column in your security mapping table, and instantly applies the correct filters across the entire model. Now, a quick pro tip here. The output of user principal name has to perfectly match the formatting in your mapping table. If one has capital letters and the other doesn't, or if you're mixing up aliases, the bouncer's not letting them in, and they'll just be staring at blank visuals.
Section 5. Testing your RLS setup. Trust, but verify.
Listen, implementing RLS without properly validating it is a massive security risk. Testing has to happen in two very distinct phases. First, you have desktop testing. You use View as Roles to simulate the logic, and you can even jump into the table view to verify the raw filtered rows behind your visuals. But desktop testing isn't enough, because it doesn't actually know who is logging in via the web. It's just a simulation. So that brings us to service testing. Once your report is published, you must use the Test as Role feature inside the dataset security settings. This evaluates the user's true Azure Active Directory identity in the live cloud environment. It is quite literally the only way to ensure full spectrum validation before you go dropping that link to the entire company.
Section 6. Best practices and pitfalls. Navigating common errors.
Okay, let's hit a rapid-fire rundown of what seasoned developers know to watch out for. First, and if you take absolutely nothing else away from this explainer, please remember this one. Users must only have viewer permissions in the Power BI workspace. If you make someone a workspace admin, a member, or a contributor, they have edit rights. And guess what? Edit rights completely bypass RLS. They will see every single piece of data in the model. This is the #1 reason people panic and think their security is broken. Second, don't mix static and dynamic roles in the same model. It just creates confusing overlapping filters. Third, ensure your data model has proper filter directions so the security filter actually flows from your mapping table down to your fact tables. Fourth, always use Azure AD groups for assigning users in the service rather than doing it one by one. And finally, remember that RLS only filters rows. If you need to hide entire columns, like say a salary column or social security numbers from a non-HR employee, you've got to step it up and combine RLS with object-level security or OLS.
So, we've covered the core mechanics, the critical architecture choices between static and dynamic types, and the absolute must-know pitfalls of configuring row-level security. Implementing RLS effectively transforms Power BI from a simple, isolated dashboarding tool into a highly secure, enterprise-grade analytics platform. It is not just about privacy, guys. It is about trust. If your users can't trust the data, or if your governance team can't trust the delivery, the whole system fails. So, I'll leave you with this to chew on. Is your current reporting setup truly secure, or are you just relying on complex, messy workarounds? Think about it. Thanks for joining me on this explainer, and I'll see you in the next one.